Okay, so this is the final question we're going to do for now. Uh, well, for you, I don't know because I've been recording straight for an hour. This is the final question I'm going to do in this single sitting. So Ben, Bidable, whatever it implements implements algorithm 2 to power n recursively to receive the zero of any positive integers. So it takes in that and then outputs that. Again, algorithms, you don't have to explain them by now. So show how 2 to power is evaluated, right? This is a funny one. Okay, so it's going to be simple. So if I create a new page there, so 2 to power 3, right? 2 to power 3. So again, if you look inside here, this function, whenever I call the function, it calls itself twice. Again, this one again, it will call itself twice again. Yeah, simple rules of recursion. So here we're doing 2 to power 3. So what happens? Inside of that one, it will call itself minus 1. And what's the stop? The stop there is when n is equal to 0. So 2 there. Again, this one will then come and be okay. 2 to power 1, t1 there, t1, t1. This will then be t0, 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 t0. Again, I'm moving through this a bit faster because it's really not what we're doing. In fact, it's fine. Now at this point, after we're done, we're then going to just cascade upwards because we're retaining a 1 at the end here. So it's going to be what we did here. It's going to be 1 1 1 1 1 1 1 1, which is just going to be 2 there, 2 there, 2 there, 2 there. That's going to be 4 4, which is going to be 8. Again, just 2 to the power n, basically. Yeah. So now we have that, it gives us 8. So we've evaluated that one. Now, to his dismay, Ben realizes that for large numbers of n, the function takes awfully long to execute, given that the running time function of 2 to the power tn is expressed like that. So we have these guys over here, and they've basically given us our recurrence relation. State the order of 2 to the power n by solving the recurrence relation. Then, what fundamental rule did Ben break? So first of all, I'm going to answer this one. So under recursion, there are rules. So you should look up the rules of recursion, and one of them is don't repeat work. Never repeat work during recursion, right? If you can find a way to do it without repeating work, do it. So that's the rule that he broke. He repeated work. But then we're going to do this recurrence relation. And then this recurrence relation, I just write it down here. Okay, just do so this is my recurrence relation, add to new page. Okay, so again, let's just solve this recurrence relation. The more of these we solve, the better. So we're going to have t of n being equal to 2t of n minus 1 plus 4. Okay, what's the next thing that we do here? Basically, what we were doing previously, this function, this guy will call itself. So it's going to be 2 open brackets. What do we replace in here? We replace this thing here, minus 2. So it's going to be t n minus 2 plus 4 outside here, which is going to be 2t n minus 2 plus 2 by 4 plus 4. Next thing is going to be 2 open brackets. Oh, there was supposed to be a 2 here, right? There's supposed to be a 2 here, so it's actually supposed to be 2 squared. Yeah, 2 squared. It's going to be 2 open brackets t n minus 3 plus 4 there, right? Plus 4 plus 2 by 4 plus 4. This essentially just gives us 2 to the power 3 t n minus 3, right, plus 2 squared by 4 plus 2 by 4 plus 4. Okay, we have this done, right? We have this. Now what goes on next one? What happens next here? What will happen next is very simple. I'm going to skip a lot of stuff and assume, because there's a pattern here again. this thing just about recognizing patterns. Once you can recognize patterns, math becomes very easy once you're able to recognize patterns. If you're focusing too much on okay, what's the next step, just recognize the pattern and then just fast. The pattern here is the fact that if we replace this for k, it's going to be 2k t n minus k plus whatever number is here will always be less than the number that's here. If we notice here, this was 2 to the power 1, here it was 2, etc. And if I continued, that trend would have continued there. So it's basically 2 to the power k minus 1 by 4 plus dot plus 2 to the power 4, or 2 times 4 and then that there. Okay, so we have our recurrence relation there. But then we assume a point where uh, let k equal n, right? We're going to let k equal n. So basically for our t of n there, right? For our t of n there, we're going to say 2 to the power k. It's already 2 to the power k, then t, then n minus k, then this is going to be for this entire thing here, I can just summarize it as a simple summation, right? Again, this is a series, so by this point you already know how to deal with series. This is just going to be plus 4, then summation up to k minus 1 starting at I is equal to 0, k minus 1 starting at I is equal to 0, k minus 1 starting at I is equal to 0 of 2 to the power I, like that there, which is basically what we have here. Yeah, again, by this point, this series you should be able to summarize it with no stress. Yeah, we've already discussed that in those free videos. Yeah, these you're supposed to be paying for them. If you didn't pay for these videos, you're a thief. And you're a thief if you didn't pay for them. Anyway, we have this over here, right? So now if we let that equal to n, this is going to be 2 to the power n, then this is going to be t of n minus n, which is just 0, plus 4 n minus 1, right? Then that's I is equal to 0 of 2 to the power I. What is t0? T0 there is 2. So it's just going to be equal to 2 to the power n, 2 to the power n times 2 plus 4 n minus 1, I being equal to 0 of 2 to the power I. We have that over there. And for finding the order of operation, really, we can forget about this guy. It's inconsequential. What's important is this over here, which is the 2 to the power n. So the order of operation here is O of 2 to the power n, because 2 to the power n was our largest one. You might ask why it's not 2 to the power n plus 1, and reason for that being is that I just get 2 to the power n. Don't trouble yourself. Yeah, 2 to the power n. And yeah, that's how you solve recurrence relations. Again, I learned how to do these a week before the exam, so you have about a month or two, I don't know. So lucky you. I wasn't so lucky. But yeah, this will be it for this topic for now. I think I've covered most of the common questions. Next thing is going to be the data structures. Yeah, peace. Well, if there are any question requests, I'm going to do videos on those. But I've covered most of the main things, unless I left out some other things. In that case, then I'll amend them in the next videos. But bye.